farmland plot. Okay, this time we have a river on one side. This is another very traditional question. A rectangular plot of farmland will be bounded on one side by a river. So we have a rectangular plot, but on one side we have a river. There we go. On the other three sides by a single strand electric fence. So we got fence on three sides and river on one side. With 1,100 meters of wire at your disposal, what is the largest area? So area, we are trying to find the largest. It means we're trying to maximize. What's the largest area you can enclose and what are its dimensions? So 1,100, what is that? Well, that's the wire, so that's the three sides in total. Now if you're going to fence the maximum amount of area, you better use all your wire. So we're going to assume we're going to use all the wire if we want to maximize. What are the dimensions of our rectangle? They tell us, so we got a label of something. So let's call the top and the bottom X. Let's call the side Y. Remember, this could be a longer rectangle, a shorter rectangle. I'm just drawing one rectangle. How we draw is kind of up to you. Just make sure there's a river on one side. Make sure two sides are labeled X and one is labeled Y. You could use other letters, length and width and height and base, but I like X and Y. Alright, so that means that our 1,100 meters is actually equal to those three sides because we have to use the wire along those two sides and use all of it. So we have 2x plus y takes care of all 1,100 meters of wire. What about area? We're trying to maximize area. What do we know about area of this rectangle? Well, area of a rectangle is simply the length times the width or the base times the height. Well, in this case, the base or the length and the width are just x and y. So multiply them together. That's the area of the rectangle. If we're trying to maximize area, we need to take the derivative of it. I am not ready to take the derivative because I don't like doing it when I have that many variables. So instead, we're going to use the equation of the wire, the 2x and the y, and we're going to use this to substitute into the area. Solve for one of your letters. In this case, y is the easiest to get by itself. So y equals 1,100 minus the 2x. Plug that into the y, and let's see what our a equation becomes. So the area is x times that new y that we just found. We got to take the derivative of that. One of the ways it's written, you can do particle, or you can do the algebra, distribute the x, and you just use power rule. So the derivative of the area is a function of x. It's going to be 1,100, the x is gone, minus 4x to the first power. That derivative is set equal to 0 to find the critical points. That's where our max and min would be. Solve for x. So 1,100, bring the 4x around, divide by 4. Alright, so what's that going to be? 1,100 divided by 4. Right, divide by 2. I'll get it out. 550 divided by 2. Calculator. 1,100 divided by 275. I did that. Counting this. New job here. Our units for meters. Put it in here, and there's the x. Is that what it asked you for? You always go back and read the question again. What is the largest area? Oh, so it wants the area and it wants the dimension. So we found x. Find the full dimensions, we need to find y. Find y, we're going to go back to this equation here. Or the one where we solve for y, it's actually better. So y is 1,100 minus 2x. So if we plug in our x, we end up with 550. And the area, which is x times y. So we take our 275, multiply by our 550, and we end up with this total area. Calculator again. Here, 275 times 550 is, wow, 151,250, and this is still meters, but we're squaring it now because we're doing area. And that answers the question. This section is very challenging. Please go back through these questions and try and do them yourself. Pretty sure this is the type of question that's in your homework. If you get stuck on a question on homework, feel free to email it to me to help you. Most importantly, draw a picture, understand what they're giving you, write it down, like I did. I wrote down the 1100, and then I figured out that that was the perimeter, basically. I wrote down what I was trying to maximize, and then I wrote down the formula for it. Then I plugged in my variables. You're usually going to have to do a substitution in these questions. Not always, but most of the time. To find a max or a min, you must take the derivative of what you're trying to maximize or minimize. Find the critical points by setting that derivative equal to 0, and that might be your answer. Go back and read the directions, see what they were looking for. Sometimes you can do a little bit more work. Hopefully this is helpful. I expect some emails from you. Good luck studying.